This colourful circle is often called the artist's colour wheel. It is used in most courses and books on colour theory for students of art or design. It is supposed to teach the science of colour. The colour wheel was first proposed by painter Johannes Itten in 1961. It suggests that if we mix these primary colours, red, yellow and blue, we will produce these secondary colours, green, orange and purple. But this is not correct. We found many reports from teachers of colour theory who complained that their students cannot reproduce the colours of the colour wheel, even not if the students exactly follow the instructions from Itten. You cannot produce any colour when you start with Itten's 3 primary colours, and if you want to produce as many colours as possible by mixing, then Itten's choice of red, yellow and blue is not the best choice. Instead, already since the 19th century, we know that for paint mixing the best primaries are cyan, magenta and yellow. There is a reason why the cartridges in your printer do not follow Itten's theory. But Itten's errors go even further, according to a new scientific article in journal Optics Express. We show there for the first time, both mathematically and experimentally, that the artist's colour wheel is indeed wrong. Optical models confirm that paint colours do not mix the way this colour wheel suggests. If you mix paints that are exactly this blue and this yellow, you probably will not produce this green. And if you mix exactly this blue and this red, you certainly will not obtain a bright purple like this. To understand why, let us look at Itten's blue primary. Its reflectance curve is something like this. With optical theory, we derive the following relations. For the red primary, we do the same. Its reflectance curve leads us to more relations. After mixing, the red and blue only produce bright purple if the resulting reflectance curve is like this. Using Duncan's rule and the previous relations, we can derive a few more constraints. But actual pigments do not satisfy all these criteria. Their colours are almost always caused by large absorption values, thus breaking several of these constraints. Our paint experiments confirm that the only way to satisfy these criteria is by mixing the blue primary much lighter than what Itten prescribes, or by making the red primary much more purple or pink than Itten's red. When we create paint primary colours, according to Itten's instructions, mixing does not produce his secondary colours. It was already known that Itten's colour wheel ignores most of the scientific developments after 1850. Our mathematical and experimental investigations show exactly how it fails. We show that there is no need to search for a better colour wheel. It is impossible to create a 2-dimensional diagram that predicts the colour of any paint mixture. For more information, please read our article, which is open access. A link is in the comments.